Hi everyone. If somebody asks you what is the condition for transistor to be in saturation, you can definitely recall this equation and you can say, yeah, has to be greater than VGS minus or VD has to be greater than VG minus VTH, and then the transistor is in saturation. Also from this equation you can derive these two conditions, the minimum voltage on drain and the maximum voltage on gate for transistor in saturation. But let's say while writing the exam, you forgot these equations. Okay. So can you write or recall and you are actually not able to recall the equation? In that case, if you intuitively understand what actually happens in saturation and triode region, I'm sure you can definitely write these expressions. Let's see how. So, when the transistor is in saturation, from the device physics point of view, we know there is something called the pinch-off region near to the drain terminal. And when it is in triode region, we know the gate potential is so high, you have this inversion charges throughout this region. Okay, there is no something called pinch-off. Okay, in the triode region. Now, what happens in the triode region? Or what actually happens in that transition region when a transistor goes from triode to saturation or saturation to triode. Let us understand. So let's say if you are increasing the gate potential, what happens? You are basically increasing the field strength in this direction. Okay, that time actually your drain potential is higher than the source potential. So if you look at the difference between the gate and drain potential, which is actually smaller than the difference between the gate and source terminal, it basically means the field strength over here is smaller compared to the field strength over here. Now you are increasing the gate potential. It means you are again increasing the field strength in this region as well, along with this region. And what will happen? Beyond a certain gate voltage, you will again accumulate the charges in this region, and there will not be any pinch off, and you will go into the triode region. So from this point of view, you can definitely write there is a limit on maximum voltage that gate can go. Similarly, what happens if you decrease the drain potential? Same thing. If you decrease the drain potential, again you are increasing the field strength in this region. Means here you are increasing the field strength. Again, same thing will happen. You will accumulate charges, and your transistor will go into the triode region. So there is a limit on minimum drain voltage and the maximum gate voltage. And what is the value? The value will be the gate voltage. If the gate voltage is more than one threshold voltage, then the drain potential, then transistor will go into the triode region, because we need a threshold voltage Vt for accumulating charges, right? That's why your gate voltage should be one threshold voltage above the drain voltage, and then only the transistor go into the triode region. And if we look at the drain potential, if it goes below one threshold voltage compared to the gate voltage, then the transistor will go into the triode region again. So you can write definitely the D mean is Vg minus Vth, and Vg max is basically Vd plus Vth. Okay, so this is how you can remember, and this is the concept. So if you remember this picture, I mean, when the transistor symbol is there in your mind, you can think about this electric field. What will happen if I increase the gate potential? Your electric field increases. What will happen if I decrease the drain potential? Your electric field will increase. So there is a limitation on minimum or there is a limitation on drain potential, on how much how low you can go, and there is a limitation on the gate potential on how much above you can go. So this is how, if you can remember or if you can understand, then definitely you don't have to remember all these things. You can instantly, looking at the symbol, you can recall the equations.